In this lesson, we're going to look at introducing imaginary numbers. And here's our focus. We're going to define imaginary numbers. We're going to derive imaginary numbers from radicals. We're going to look at how to add and subtract imaginary numbers, and also look at multiplying and also dividing imaginary numbers. Now, let's get started. So, an imaginary number is one that, when squared, resolves in a negative number. So generally, an imaginary number cannot be drawn on a number line, and you cannot even use it on your calculator, on a regular calculator. So anytime you have a negative number as the radicand under the square root sign, you're going to end up with an imaginary number. For example, we have square root of -2. The fact that you have a negative number under the square root sign, you're going to end up with an imaginary number. Square root of -24, square root of -16, square root of -100. All these are going to lead to imaginary numbers. Now let's look at how we can evaluate an imaginary number from a radical. Here we have the square root of -4. So what we're going to do here is remember that what we want to remember is -4, the square root of -4 is the same as the square root of 4 multiplied by the square root of -1. So square root of -4 is going to be, what is the square root of 4? That's going to give us 2, and the square root of -1 is I. So we have 2i. Now the square root of -75 is going to be equal to the square root of 75 multiplied by the square root of -1. For 75, let's do this. Let's draw factor trees. We have 3 and 25, and when we decompose 25, we have 5 and 5. So we have 5 square root of 3. So we have 5 square root of 3, and then multiplied by I. Generally, the best practice for this is we're going to attach the I to the 5. So 5i square root of 3. So that's the simplified version here. Now let's look at adding and subtracting imaginary numbers. So we have a common term here. So we just say 4 plus 7, and then we put an I at the end. So that's going to give us 11i. Here we have 8i minus 5i. So we have common terms. So it's going to be 8 minus 5 with an I at the end. It's going to give us 3i. Okay, now let's look at this where we have to actually evaluate radicals. We're going to rewrite each of these as imaginary numbers first. So look at 8. Just remember that when you have any negative number, so let's call it AI. So let's call it -a. This is going to give us the square root of a multiplied by the square root of -1. So we're always going to end up with I square root of a, whatever that ends up being. So look at 8. We have 2, 4, 2, and 2. We'll go through 50 as well. 50 is going to give us 225. Then we have 5 and 5, and then 18 is going to give us 2 and 9, and we have 3 and 3. So we're going to rewrite each of these radicals here as imaginary numbers. So square root of -8 is going to give us 2i square root of 2 plus 5i square root of 2 minus 3i square root of 2. So now what we have is we have common radicals here, so we can work with the coefficients of these radicals. So we have 2i, we have 2i plus 5i minus 3i and all of that square root of 2. So 2 plus 5 is 7 minus 3. That's going to go as 4i square root of 2. Now, when we're multiplying imaginary numbers together, it's very important to remember that when we have I multiplied by I, we're going to have I squared. Also, remember that I is the square root of -1, so I squared is going to end up being -1. So 6i multiplied by 5i is going to be 6 times 5 and then I squared, which is 30i squared. But I squared is going to be equal to -1, so it's going to be 30 multiplied by -1, which is -30. Let's look at this example. So now we have 12i multiplied by -4i. So we have 12 multiplied by -4, and then we have I squared. This is going to give us -48 I squared, but I squared is -1. So -48 multiplied by -1 is going to give us 48. Now let's look at this one here, square root of -49. So let's look at the square root of 49 is 7, and then we have an I because it's a negative sign, multiplied by the square root of 16 is 4, and then we have an I. So this is going to give us 28i squared, which is 28 multiplied by -1, which is going to end up being -28. What about this? Look at 18. Our factor trees here, 2, 9, 3, and 3. 32. Our factor trees are going to give us 2, 16, 2, 8, 2, 4, 2, and 2. So we have one pair here, one pair here. So this is going to give us 3i square root of 2 multiplied by 4i square root of 2. So here are the groupings we're going to have. 3i multiplied by 4i, and then we're going to multiply square root of 2 by square root of 2. So this is going to give us 12i squared times 2. So this is 24i squared. And we know that I squared is equal to -1. So it's going to be 24 multiplied by -1, which is going to give us -24. Now let's look at dividing imaginary numbers. One rule we want to pay attention to is that you cannot have an imaginary number in your denominator. So one easy way to get rid of the imaginary number is multiplying it by, so we have 4i over 5i. We multiply by I over I. Remember that I over I is equal to 1. So we're actually multiplying this by 1 in order to show that we're not changing the fraction at all. So we're multiplying by I over I. The only reason for that is to get rid of the I from the denominator. We can have I in the numerator, but we cannot have an imaginary number in the denominator. So this is going to give us 4i squared divided by 5i squared, which is going to give us 4 times negative 1 divided by 5 times negative 1. So we can cross this out, and it's going to give us 4 over 5. Some may say you can just cross out the I, but I usually don't subscribe to that approach. I like to show that you actually have a process to follow to eliminate the I from the denominator. Now let's try this using the same method. So we have 6i divided by 13i, and we're going to multiply by I over I because this is going to be 1 and the fraction is unchanged. So this is 6i squared divided by 13i squared, which is 6 multiplied by negative 1 divided by 13 multiplied by negative 1, which is 6 over 13. Now let's try one example here. Let's try something like 5 over 6i. So what we have here is we multiply by I here. So this is going to give us 5i divided by 6i squared, which is 5i divided by 6 times negative 1, which is going to give us 5i over negative 6, which ends up, we can bring out the negative sign here, and it becomes 5i over 6. So we have negative 5i over 6. So that's an example to show you why it's always important to follow the right method as you try to evaluate fractions that have imaginary numbers in the denominator.